Hello everyone, and welcome to the first lecture in our video series on digital communication using MATLAB Simulink. In this series, you will learn how to use MATLAB Simulink to model and simulate digital communication systems. I'll be using MATLAB version 2018b for this series, but higher versions are also available and can be used. So let's start using double-click the MATLAB desktop shortcut icon on your PC. Upon launching MATLAB, you'll encounter three prominent tabs within the main window: the current folder, command window, and workspace. To access Simulink, click on the Simulink button. A dialog box will emerge, presenting the options to craft either a blank model or a project. A separate tab is dedicated to illustrating examples, which can be immensely helpful. Returning to our focus, start with a blank model. Components can be incorporated from the Simulink library by dragging and dropping them into your workspace. To access this library, simply click on the Simulink Library option situated on the toolbar. This repository houses an array of available Simulink blocks. Throughout this lecture series, our primary emphasis will revolve around the art of constructing digital communication models. To achieve this, we'll leverage blocks not only from the fundamental Simulink block library, but also from the Communications System Toolbox and the DSP System Toolbox. Let's start with a simple example. Go to commonly used blocks and drag the scope in the model. Now, go to Sources and drag the sine wave to the model. Feel free to rename these blocks for clarity. For instance, consider naming the sine wave block as Sine, and the scope block as Display. You can also customize the name of the model itself. This can be achieved by accessing the menu bar and saving the model with a new name. To modify the parameters of the sine wave block, initiate a double click on it. A window will appear, enabling you to set various parameters such as frequency, amplitude, and bias. For the time being, maintain the default values except for frequency, which can be altered to 5 Hz. Following this adjustment, execute the simulation using the Run button. To visualize the results, double-click on the Display scope. It's noteworthy that the sine wave's perfection is due to its plotting using a limited number of points. To address this, double-click on the sine wave block. Observe that it's configured as a time-based sine wave with a sample time of 0. Adjust the sample time to 10 raised to the power of -2. Run the simulation again, and you'll notice an improved resolution in the sine wave. Now, let's explore the generation of multiple sine waves. Double-click on the sine wave block, and within its parameters, input two frequencies in the form of a vector. MATLAB requires matrix inputs for this purpose. Following this modification, rerun the simulation to obtain two sine waves, each with frequencies of 1 Hz and 5 Hz. Continue by experimenting with the amplitude and bias points of the sine wave. Define the desired amplitude and bias points using matrices. Run the simulation again to observe the outcomes. Additionally, consider the impact of reducing the sample time. Set the sample time to 0.1. Run the simulation again. You will notice that resolution of the graph decreases. Now, explore how to plot sample-based sine instead of time-based sine wave. Double-click the sine wave block and change the sine type from time-based to sample-based. Now you will notice that instead of frequency, samples per period appear in the options. Set the sample per period to 50. Now, run the simulation to check the results. Finally, we will discuss how we can send and store data within the workspace. To achieve this, incorporate an additional block from the library called SimOut into the model. Following the simulation run, examine the workspace. The values from the simulation are stored therein, and you can even export this data in the form of a Microsoft Excel file. And that concludes our first lecture. In our upcoming session, we'll delve into the realm of communication, exploring it in depth. Thank you for joining me today, and I look forward to embarking on this learning journey together.